It's like graph. It's better. I'll tell you, I'll give you this, hold on, it's not leaving it.
Okay. So again, 1.1 functions with an equation or a formula, 1.2 functions with a table. We are currently in 1.3, which is functions from a graph. And on Wednesday, we talked about being able to look at the graph and determine if it is increasing, decreasing, increasing. And then at the top of the hill, so to speak, is your maximum, your highest amount. And then the bottom of the valley is your minimum. So we looked at that on Wednesday. And then we went into the discussion of concavity, which tells us the curvature of our graph. And so we looked at examples of concave up, concave down. And so I just want to remind you that look for if you have cups up or cup down. That helps you determine if it's concave up or concave down, okay? So I wanted to go over that again today because the first thing that we're going to look at today deals with concavity. And it's what we call an inflection point. All right, so before we get into the definition, what we talked about on Wednesday, we could say increasing maximum, decreasing minimum, increasing. Decreasing minimum, increasing maximum, decreasing minimum, increasing, okay? Then we talked about the curvature or concavity. Well, when you look at this A, what would you, from what we talked about on Wednesday in concavity, what is something you see or might recognize? Think cups up, cup down. Both of them, right? I would agree. Part of it is cups down. So here our concavity would be down. Part of it is cups up, which would be concave up. So we can see that one graph can have multiple curvatures. Here, I start here, what is that? Concave up. And then if you look here, then it goes to concave down. And then if you look here, it goes back again to concave up. So different curvatures. All right, so that sets us up to talk about what is called the inflection point. An inflection point is where the graph changes concavity. So we went from concave down to concave up. So what that tells me is that approximately here, there is a point called the inflection point. I'm going to use IP to represent inflection point. So at this point, it tells me my curvature changes. It went from concave down to concave up. Whereas up here is the maximum and minimum. This point's what we call the inflection point. So when I'm looking here, I know I have concave down, and that at some point about approximately right here, you hit your inflection point and the curvature changes to concave down, and that at an inflection point, the curvature changes to concave up. Now, what occurs at the inflection point? This is important to know because you may be asked, hey, what's going on at the inflection point? The inflection point is where the function is either increasing or decreasing most rapidly or the fastest. Okay, here's what that means. If I say my function was money, so we're talking about I invested money, and so the function is the returns on my investment. So this would mean my money value is going up, it hits a maximum, and then it starts decreasing, which is basically means I start losing money, right? At this point here, that's where I'm losing money because this is decreasing at the fastest rate. Which of course I'm not gonna like, right? Here, if we were talking about money, it's like I do an investment, bam, the market drops, I hit a minimum and I'm freaking out, losing all this money, and we have a turn in the market, and now I start making money again. This point right here is where my investment is increasing the most rapidly. And then we go, okay, I made a rebound, oh darn it, it starts going down again, here's where it's decreasing most rapidly. Okay, so that's what the inflection point represents. All right, one of the things, and we'll get into it more next week, is you're going to be required to interpret the concavity of graphs. And this is very specific, so I'm going to show you exactly how it will be written. Because when I ask you to explain about its concavity, you have to tell me what it's doing based upon what we're getting ready to talk about. All right, so this says that our graph is concave up and it's increasing. Okay, so let me give you an example of what that might look like. So I know I'm concave up and it's increasing. So concavity with an increasing graph would look like this. All right, so if we were asked to describe or interpret, or you may see the wording describe the function, then what I'm asking you to tell me is, based upon this, you can say, okay, I know that the function. Now, if I knew what this was, like if I knew if it was the return on investments or money, I would say the return on the investment is, so you always have to tell me what the function is. I'm just doing a general sentence right now, okay? So the function is, okay, with this from left to right going up, we know that, so to speak, I'll say the money is doing what? Increasing. So I'm going to say the function is increasing at, and then this is what the curvature tells me. It's increasing at a particular rate. So when I look, I know that with this arrow here, this means it keeps going up and up and up and up and up. So would you tell me that my investment or my money is going fast or it's slowing down? It's going fast. So we would say at an increasing rate, which if this was an investment, that's what I would like to see. And so the things I'm looking for is that you know that the graph is increasing and that you know it is at an increasing rate. So I'll be looking for those words when I grade those sentences or those describes or interpreted. All right, another example is when we still have concave up, but now it is decreasing. So concave up, but it is decreasing. So that graph would give me an example of it's decreasing, it's going down, and my curvature is cups up, so it's concave up. All right, so in this case, I would say the function is, and if it's going downward, it is decreasing at a, now think about this. So my investment, so here's what this would talk about money over here, right? I have all this money and bam, it starts decreasing. But is that decrease slowing down or is it still dropping to the bottom of the barrel? It's slowing down, so we would say it is decreasing at a decreasing rate, which means, hey, it's still going down, but not as fast. So a decreasing rate means it is slowing down, which, what would that look like on your graph? Your graph is leveling off. And so again, I'm looking to know that you know the graph is decreasing and that it is a decreasing rate. All right, concave down, increasing. All right. It is increasing and my curvature is cups down, but we have concave down. All right, so again, I would start out as, because these will be complete sentences, right? So the function is, oh, I get spelled function. I started writing is first. The function is, okay, what is this function doing? Increasing at A, and ask yourself, is it slowing down or is it not? It's slowing down, so we know the rate is decreasing. Because rate deals with the speed. So the speed of it increasing means it's basically slowing down. So like if we were talking about money, I'm making a lot of money and then say I hit $1,000, well then it starts slowing down. So I'm still making money, but not as fast. From here to here, I was making money really fast, but here it starts slowing down. All right, then the last one, it's concave down, decreasing. Oops, my horizontal axis is not very level. Sorry about that. All right, so in this example, the function is what? Decreasing. At what kind of a rate? Increasing, because man, that thing's gonna bottom out. So next week, when we start looking at examples in 1.3, we'll look at graphs and then you'll have to say like, the return on my investment is increasing at a decreasing rate. So, hey, I'm still making money, but it eventually slowed down. Okay, so you've got to start having an understanding of what that means and it represents. And so